Hello guys, welcome to my channel. In this video I'm going to talk about the Numpy arrays, and this is going to be the third video on Numpy implementation. So let's get started. So before starting I want to explain a few ideas of Numpy arrays, like the axis, as I promised before. So you see here two-dimensional array or a matrix where we have axis 0 and axis 1. So axis 0 simply means along the columns, and axis 1 means along the rows. For example, you have used the function maximum over some array along the axis 0, and it looks for every column and figures out the maximum element. For example, in the first column along the axis 0, your maximum element is this one, the second one, this one, this one, this one, this one, and so on. And the same for axis 1 along the rows. Maximum element might be here, here, here. So in this case, how many elements you will have? The maximum elements along the axis 0. So in this one, this one, this one, this one, this one, 1, 2, 3, 4, 5. So you will have 5 maximum elements along the axis 0, and you will have 1, 2, 3 elements along the axis 1. So let's implement the code. So as always, I start with implementing the Numpy library, importing Numpy library, and I create a random array. So is equal to mp random dot, for example, randint from 9 to 21, and the size going to be 4 by 5. And let's see what we have in the array. You see the random numbers and dimensions 4 rows and 5 columns, 4 by 5 matrix, and I will use the maximum function along the axis 0. So print np.max array, and axis is 0. The second one, max array, and axis is 1. And you can see for the axis 0 I should have 1, 2, 3, 4, 5 elements. For the axis 1 I should have 1, 2, 3, 4 elements, and it looks for the maximum elements in each column in the axis 0 and in each row for the axis 1. You can see in the first column the maximum element is 20. You can see the 20. In the second, 17. You can see the 17. 15, 19. You can see the 19, and 17. In the first axis you can see 17, 18, 19, and 20. And we can do the same thing for minimum elements. Print np.min array and axis 0. Yep, and let's see what we get. Oops, I have all the yep, it works. We can use the same functionality for finding standard deviation, minimum mean value like average value, summation, concatenation, and so on. Let's implement a few. For example, print mp.sum array, and I will get 220. So this function has been implemented in such a way that when you don't write any axis, so it sums all the elements inside the matrix up, and if you add all the elements in this matrix, you will get 220. But if you write the axis is equal to 0 and 1, it will sum the elements in the first column for the axis 0, and the second one, the third one, which means for the axis 0 still I should have 5 elements, but added up all the elements in each column, and for the same thing in axis 1 we'll see 34 for the axis 0. We can prove that 4 plus 8 plus 2, 14, and 20, 34, 23, 44, and 34, and 46, and so on. We can write for the std function standard deviation Yep, it works. And last thing, I will explain the concatenation. So let's see what happens if we want to use the addition sign for two numpy arrays having the same size. So r1 is np.array 1, 2, 3, 4, 5. And I want to add it adds up the corresponding values 7, 9, 11, 13, 15, which does the same thing like the numpy function called addition, or simply mp.add. When you add the second array to the first array, they are not going to be the one array. Like you don't take the second array and put it to the end of the first array to get the third array having this size, which is the sum of the sizes of two arrays. Like how we can create an array starting from 1 and ending to 10, all the elements in array 1 and array 2. So we can do that using concatenation function. R is equal to mp.concatenate, and array 1, array 2, you have to write it in brackets, and then you write the axis 0 and print array. So you can see along the axis 0, the elements are added. We will have the elements in the same row. If you write axis 1, so let's see what we get. Well, we don't have the axis 1 because our arrays are one-dimensional. So I probably should add the second dimension. Let's check for the first case. Axis 0 and axis 1. The axis 0, it adds along the rows for the axis 0, but for the axis 1 it puts the array together in the same line, because we said for the axis 0 we are talking about the columns, but in the axis 1 we are talking about the rows. For the axis 0 we get two arrays, two-dimensional arrays, and they are not put side by side, but instead along the rows. And that's it for the concatenation function. And let's see, we have the addition, subtraction, multiplication, division. It is nothing but using plus sign, minus sign, multiplication sign, and so on. For example, print R1 plus R2, and we can see the result. It will add, it will subtract, it will multiply, and it will divide the corresponding elements. We can implement the same thing using the Numpy functions. For example, print mp dot add, and you have to insert the names of the arrays, and it will automatically, using AI, will write subtract, multiply, divide, and so on. And let's see if we get the same answer as before. Yep, we get the same answer as before. So which means if you want to write a code that is in an elegant way, you can use these functions. But if you don't want to be too long in a code, or you want to be simple, so you can use the signs: addition, subtraction, multiplication, division, and so on. So guys, that's it for this video. I hope this video was helpful for you, and I will explain the more concepts in Numpy arrays. Then we will move on to pandas library, maybe some matplotlib, cbor, and so on.